The question we're going to look at in this video is as follows. Find the values of x at which the equation g of x equals 4x cubed minus 13x squared minus 30x plus 72 has stationary points. We must first differentiate the equation. We must note the powers 3, 2, 1 and 0. Firstly, we are going to multiply the x coefficient by the power. For example, the power of 3 multiplied by the x coefficient 4, 2 multiplied by minus 13, and 1 multiplied by minus 30. We end up with 3 multiplied by 4x to the power of 2, minus 2 multiplied by 13x, minus 1 multiplied by 30. You will notice here that the 72 has disappeared, and that is because the x was to the power of 0, and 0 multiplied by 72 leaves us with 0. When we multiply out the brackets, we end up with 12x squared minus 26x minus 30. In order to find the stationary points, we must solve this quadratic equation for x. Therefore, we factorize this quadratic equation and come up with 6x plus 5 multiplied by x minus 3 equal to 0. We have two possibilities here to find x. 6x plus 5 equals 0 or x minus 3 equals 0. To find one solution for x, we look at 6x plus 5 equals 0. We must minus 5 from both sides, which will leave us with 6x equal to minus 5. We will do the same thing for the other solution of x. Only this time we're going to add 3 to both sides, leaving us with x equals to 3. The last step is to divide both sides by 6, leaving us with x equal to minus 5 over 6 or x equal to 3. From this, we can say that the equation g of x equals 4x cubed minus 13x squared minus 30x plus 72 has stationary points at minus 5 over 6 or 3. For the second part of this question, we are asked which word and number correctly fill in the blanks in the following sentence. The function f of x equals minus 4x squared plus 14x plus 91 equals 0 has a local blank point at x equal blank. It is important to note the minus sign in front of the 4x squared. It is also important to note the plus sign in front of 14x. In order to complete this question, we are going to differentiate. We know from the previous part of the question that when we differentiate, we take note of the powers. The powers here are 2, 1 and 0. In order to differentiate this equation, we are going to minus 1 from each of the powers. Likewise, we multiply 14, the x coefficient, by the power, which was 1, and then we minus 1 from the power. We end up with the differentiated equation equal to minus 8x to the power of 2 minus 1 plus 14x to the power of 1 minus 1. When we simplify this, we end up with minus 8x plus 14. The next thing we must do is solve for x to find the point, and then continue on to find the second derivative in order to figure out whether it is a local maximum or local minimum. To find x, we let minus 8x plus 14 equal to 0. The next step is to minus 14 from both sides. We end up with minus 8x plus 14 minus 14 equals minus 14. This leaves us with minus 8x equals minus 14. To find x, we divide both sides by minus 8. X will then equal minus 14 over minus 8. Therefore, x equals 14 over 8, which can be written as a decimal. X equals 1.75. The next thing we need to do is find the second derivative in order to find out if the point x equals 1.75 is a local maximum or a local minimum. To find the second derivative, we differentiate the first derivative. We will end up with the power 1 being brought to the front and multiplied by the minus 8x, which is to the power of 1 minus 1. Therefore, the second derivative equals minus 8. The rule is that if the second derivative is less than 0, then it is a local maximum. If it is greater than 0, it is a local minimum. Therefore, the function minus 4x squared plus 14x plus 91 has a local maximum point at x equals 1.75 because the second derivative equals minus 8, which is less than 0.